Okay, so in iron carbide phase diagram, okay, you should know that there will be 5 solid phases, which is delta ferrite, gamma austenite, alpha ferrite, and cementite, and ferrite plus cementite, which is equal to perlite. Okay, so delta ferrite is happening before at the very high temperature. Okay, here delta ferrite. Okay, and then gamma austenite is at the purple region here, alpha ferrite here, and cementite is at the end of your phase diagram, and perlite is here. Okay, so remember these solid phases will be fixed. So delta ferrite, okay, so these are the things that you should know about the solid structure. So for delta ferrite, okay, it is basically a BCC crystal, okay, and it exists at very high temperature, okay, and it is the maximum solubility, okay, the maximum solubility of carbon in ferrum is at 0.09%. Okay, here 0.09. And for austenite, okay, now the crystal structure has changed, okay, from BCC, from delta ferrite, it becomes austenite. For delta ferrite just now is a BCC crystal structure, and when it changed to austenite, okay, it will be changed into FCC crystal structure. Okay, and the maximum solubility of carbon in austenite is 2.14%. Okay, this is the maximum solubility of carbon in austenite region, 2.14. And for alpha ferrite, okay, now you can see that from BCC it changed to austenite, it becomes FCC, and then when it changed to alpha ferrite, okay, it changed into BCC crystal structure. Okay, now it has the sulfur structure, okay, and the maximum solubility of carbon is 0.022 weight%. Okay, 0.22 weight%. For cementite, okay, cementite or Fe3C, okay, now cementite is an intermetallic compound, okay, because it has a fixed amount of carbon and a fixed amount of ferrum are needed to form cementite. Okay, so basically it is this carbon plus ferrum, in order to become cementite, okay, it must be the amount is fixed. So what is the amount? Okay, it contains 6.7% of carbon and 93.3% of ferrum. So that is why it is happening at the end of your phase diagram, 6.7. Okay, when you are adding 6.7% of carbon, then only it becomes cementite. Okay, if let's say you are adding 6% of carbon, okay, it hasn't become cementite because it is still at here. Okay, cementite is only happening when you are adding 6.7% of carbon, because this amount must be fixed. Okay, and then for perlite, okay, it is resulted from transformation of austenite of eutectoid composition on a very slow cooling. Okay, so the structure of perlite, it has lamella structure. So remember, lamella ni is the alternating layers, okay, of ferrite and cementite. Okay, so basically in this is not from microscope, this is from SEM if I'm not mistaken. Okay, the perlite microstructure will be observed like this, where it is in lamella structure. It has cementite and ferrite. So in this iron and carbide phase diagram, okay, we can see there are three invariant points. So three invariant points, okay, a little bit of recap is where at that point a material can exist in three phase. Okay, so remember, like in chapter 2.2, okay, we have learned about the eutectic reaction where liquid will be transforming into two solid. Okay, so in this case, the eutectic region is happening at A. Okay, so let's see, liquid will become two solid structure, which is gamma plus cementite, austenite plus cementite. Okay, and then some more at B, we also have another reaction, okay, which is eutectoid. So from eutectoid, okay, it is from a one solid, it will be transforming into another two solid. Okay, so in this case, the reaction happen is from gamma austenite, it will become alpha plus cementite or pearlite. Okay, and then the next invariant point, okay, is peritectic at C. Okay, so here what happened is, okay, the transformation is from two solid, it will become into one solid. So it is delta plus L. This one is delta plus L. It will become alpha. No, I think this one should become gamma. This one delta plus L. It will become gamma. Okay. So these are the three phase diagram that happen. Okay, eutectic reaction will be liquid at 4.3 weight% of carbon. Okay, and this value will be fixed. Okay, it doesn't, dia tak akan jadi berbeza-beza, dia mesti fixed sebab this one is a fixed phase diagram, which is phase diagram for iron carbide. And then this, okay, if you look at all the value here, it will be fixed. Okay, remember, it will be fixed. So when eutectic reaction will become liquid at 4.3 weight% of carbon, it transform into gamma plus cementite. Okay, for eutectoid reaction, it will be happening at 0.76 weight% of carbon. Okay, here 0.7% of carbon. Okay, and for peritectic reaction, it will be happening at 0.1 weight% of carbon, and then it will be transforming into its respected solid. Okay, so now we are going to learn about the hyper and hypo eutectic and eutectoid. So this is basically in this region. Okay, this one is the eutectic region, okay, which is similar as what we have learned from chapter 2.2. Okay, only the difference is now we are going to have a very specific value, 4.3 weight% of carbon. Okay, it will become eutectic reaction. Okay, so now this one is eutectic point, so we have to make this underline here, and to the left of your eutectic point, it will be hypoeutectic, and to the right of your eutectic point, it will become hypereutectic. But for in chapter 2.3, okay, because we have learned about this eutectic region, hyper and hypo, from chapter 2.2. So basically the question, when it comes to chapter 2.3, okay, the question usually focus on the eutectoid. Okay, so that is why the objective just now at the beginning of the lecture, I told you about you should be able to identify the hypo and eutectoid region of iron carbide phase diagram. So this one, now we know that the eutectoid region is happening at 0.76 weight% of carbon here. Okay, and then just make an underline here. So to the left of your eutectoid point will be hypoeutectoid, and to the right of your eutectoid point will be hypereutectoid. So it will end until here, because obviously after this point it will become eutectic. Okay. So then allotropic transformation. So what is allotropic? Allotropic ni is a material that can exist in more than one lattice structure. Okay, just now I told you about the BCC. Okay, delta, it is in BCC crystal structure, and then it becomes gamma austenite, it will become FCC, and then when it change to alpha ferrite, it will become BCC. So this one is allotropic transformation. Okay, so we can see here at room temperature it exists as ferrite or alpha in BCC crystal structure, and when we heated it up, okay, to 912 degrees Celsius, it's become austenite, which is arranged in FCC crystal structure. And then further heating, okay, it will result into austenite will become the BCC crystal structure, which is we call it as delta ferrite. Okay, so basically this one is what happened lah. From delta BCC, it will become austenite FCC and alpha iron. So this is all you need to know about the allotropic transformation. Okay, and then for the microstructure, okay, so the microstructure, it depends on the composition of carbon and also the heat treatment, meaning that the temperature. Okay, there's 3 significant region, okay, which is eutectoid, which is happening at carbon of 0.76 weight% and temperature 7 to 7. Okay, remember this one all will be fixed and it entirely consists of pearlite. Okay, the result will become pearlite. For hypoeutectoid, okay, which is left of your eutectoid point, okay, the carbon content is from 0.02 until 0.76. It consists of pearlite and primary or proeutectoid ferrite. Okay, we will see a little bit clearer just later. For hypereutectoid, which is to the right of your phase diagram, okay, the carbon content will be from 0.76 until 2.14. Okay, it consists mainly of pearlite and proeutectoid cementite. Okay, so these are the structure of the eutectoid steel, okay, which is at 0.76 weight% of carbon. Okay, the austenite will become pearlite, and the microstructure will be in alternating layers of pearlite, where pearlite, remember pearlite is alpha plus cementite. So it will become like this alpha, the blue one will be alpha, and it will be in alternating layers of cementite. Okay, so how about the microstructure for hypo and hyper? Okay, so for hypoeutectoid, okay, remember hypoeutectoid is happening to the left of your eutectoid region, which is from, okay, if we want to know details, we have to know about the hypoeutectoid must be from 0.02 until 0.76. So this one is 0.02 until 0.76. Okay, this is 0.76. So the result will be, okay, hypoeutectoid, this one, hypoeutectoid, it will be in what form? Okay, let's look at here. hypoeutectoid will be in alpha plus cementite. Okay, but just now, okay, in eutectoid it will be in perlite, okay, alpha plus cementite. But hypo and hypereutectoid ni, it will be happening just below your eutectoid point. Okay, so meaning that microstructure will be changed. Okay, so how does it change? Okay, the perlite ni tadi, okay, the microstructure will become plus the, instead of only perlite, just like from eutectoid just now, okay, it will also have a proeutectoid ferrite, this one. Okay, why does it become like this? So nanti saya akan tunjuk later. Okay, and for the hypereutectoid, which is to the right of your eutectoid point, okay, similar, because it has undergone eutectoid, so it will, the structure will have the perlite layers, and plus because it is happening just below your eutectoid point, so it will also have some cementite, which is proeutectoid cementite. Okay, so dia akan ada macam ni. So kenapa dia jadi macam tu, nanti later on I will show you. Okay, so like this one, for eutectoid steel, okay, this one is the eutectoid, which is 0.76 weight % of carbon. Okay, before the eutectoid temperature, which is 712 degrees Celsius, before eutectoid, okay, all of the solid will be in gamma phase. Gamma. Okay, it is solid, so it has become a crystal structure, but now all of these are in gamma form. And then when you are cooling down the material, okay, when you are cooling down the alloy, okay, at 0.76 weight % of carbon, okay, the structure will become in alternating layers of perlite. Okay, meaning that all of this gamma, okay, will be changed into alternating layers of perlite. Okay, so the gamma will be transformed into alternating layers of alpha plus cementite. Okay, so at the hypoeutectoid steel, remember hypo here. Okay, so kita tengok sini lah. At the hypo, okay, so this is your eutectoid point, remember, at 0.76 weight % of carbon. So to the left of the eutectoid point will be hypo. This one is hypo. So let's look at the point C. At point C, okay, the structure will exist in all gamma form. Okay, and then you cooling down the alloy, okay, from 900, become 780 degrees Celsius at D. Okay, at D here we can see the, okay, here is it exists in alpha plus gamma. Okay, so now the structure, okay, this one is alpha plus gamma. So the structure will become gamma, and some of the alpha will be started to form. Okay, and then you further cooling down the material. Okay, further cooling down the material, okay, we can see that now the alpha or the ferrite just now will grow. It will grow and become crystal. but the gamma still there. Okay, all of these gamma are still there. So let's say I colored with this. Okay, so this gamma in pink. Okay, and then the eutectoid temperature happen. So, and then dia jadi kat sini, at here, at eutectoid, dia akan jadi in lamella lah. Okay, lamella yang macam ni. Okay. Sorry. So, that one is at 0.76, but now we are looking at here. Okay, now we are looking at before 0.76. Okay, so let's say this one is 0.3 weight percent of carbon. Okay, so and then further cooling down the alloy at F. Okay, so now we can see that, okay, the gamma tu, okay, all of the gamma yang pink ni, the ferrite ataupun alpha were still there. Sebab dia dah mengeras, dia dah jadi crystal. So it cannot change. Now, apa yang kena berubah adalah all of the gamma ni will be in alternating layers. So, ni dia akan jadi pearlite. Okay, here dia akan jadi pearlite. Ni dia akan jadi pearlite. Ni dia akan jadi pearlite. Okay, so yang biru ni, the blue one, we call it as pro-eutectoid alpha. And all of the gamma tu will be changed and become pearlite. So, let's look at the transformation. So, from gamma, okay, it will become pro-eutectoid ferrite. So, this one we call it as pro-eutectoid ferrite. This one. Okay, this is pro-eutectoid ferrite plus gamma. Okay, because it hasn't it hasn't cooled down below the eutectoid temperature. Okay. And then when we are further cooling down the alloy, okay, we can see that pro-eutectoid ferrite now has hardened and become crystal. So, it cannot be changed. So, it stay. Okay, pro-eutectoid ferrite. And all of the gamma ni, okay, will be because it has undergone the reaction, eutectoid reaction. Remember, eutectoid reaction is from gamma. It transform into alpha plus ferrite. So, all of these gamma now will change into alpha plus cementite. Okay. So, it becomes pearlite. Okay. That is how that is how the transformation happen. That is why, okay, why there is a pro-eutectoid alpha and why there is a pearlite in hypo. And hyper, why we don't have the pro-eutectoid alpha? Why it become pro-eutectoid ferrite pula? Cementite pula. Let's see how. Okay. So for hyper-eutectoid, which is happening to the right of your eutectoid temperature. So remember, this one is eutectoid temperature, 0.76 weight percent of carbon. Okay, so here at G, all of the phases will become gamma. Okay, and then at H, okay, so what are the region exists at H? So at hyper here, okay, it is in gamma plus cementite. So therefore, the gamma will stay and then the cementite will be started to form. Okay. But the gamma will be stay. Saya buat warna purple. This purple. Okay, so the green one ni, the green one is the pro-eutectoid cementite, and the pink one is the gamma. Okay, so after we further cooling down the alloy, okay, until it reach the eutectoid temperature, okay, now we can see that the cementite, okay, which is started to form just now, will become crystal. So this is pro-eutectoid cementite. It will start to grow. Okay, and then all of the gamma ni will be transformed into pearlite. Okay, so let's look at the transformation. So from gamma, and then it will become cementite plus gamma. Okay, this one pro-eutectic cementite, the green one. And then at some point, okay, when we are further cooling down the alloy, the pro-eutectic cementite will started to harden and it will become crystal, so it cannot be changed and it stays. Okay, the only thing that can be changed is gamma, because eutectoid reaction. Eutectoid reaction is gamma. It will become alpha plus cementite or ferrite or pearlite. Okay, so this one is eutectoid reaction. So the all of the gamma will be transforming into pearlite. So that is why we can see that the hyper-eutectoid microstructure will be like this. Pro-eutectoid yang ada, instead of pro-eutectoid alpha, it is pro-eutectoid cementite. And the rest of the pearlite tu is similar as your hypo-eutectoid steel.